Well, hello everybody. Welcome to Blue Marble Science. Today we got Brian's logic, the Blackpool Tower, and some really wrong geometry. Hey, grab those oven mitts and push those monitors back out of the way. Let's see if Brian can light a dumpster fire all by himself. Now, this is about this very beautiful photograph taken of Blackpool Tower, that's on the western coastline of England, with some mountains in the background. So you see Blackpool Tower there, and you see Dow Crag behind it and below it. Brian's got the idea that this somehow or the other proves the earth is flat. Let's give a listen to his reasoning here.
Well, how are you doing? Okay, this video is going to be called Blackpool Revisited. We all remember, if you were around at the time, back early last year, I think it was, in 2021, this whole Blackpool photograph thing turned up with all this nonsense. And I ended up having a 5-hour debate with Ranty on Conspiracy Cast channel over it. And there was a lot of back and forth, but it was proven that it wasn't proof of a globe at all. And one of the arguments I made, and I didn't have this software or know about this didn't have my head screwed on, should have been looking for it. One of the arguments I made at the time was this, and I made this within the debate with Ranty. And he conceded on it, actually. He conceded on it. We had a break and he conceded on it afterwards. And I don't really care what he has to say about it. He can look at or anyone can look at the debate. It's on Conspiracy Cast channel. It's a 5-hour debate. The point I made was this, right? This was an orthographic view viewed within, I was going to make it bigger, within, there's an elevation profile from Google Earth. Here is the observer about 20 foot. Here is 520 foot high Blackpool Tower. There's the line of sight. So with this line of sight, if we bring it over, it seems to intersect the top of Dow Craig, right? But the problem is this. Look at the height of Dow Craig. It's about half a mile high. So if you take this half a mile high and you look at the distance between Blackpool Tower here and this half a mile high, because it's an orthographic view, they can just make this big, small, this area in between big or small. The point is that this half mile high is not the distance between here and here. That was my point. So there was no point in, like Randy was pointing out, that the intersection line touched the top of the mountain. Yeah, but that's when there's only this much distance between them. In reality, there's a much bigger distance between them. So let's make it bigger. So, right. So if the line continues on, this red line, this is the observer's line of sight. Once they're looking over the top of the tower and the line continues on, and we move the mountain back a bit, because we move it back here to be about 8 miles away. It's about 4 miles away here, about 8 miles away back there, maybe, or more, maybe more, whatever. The point is that as we move the mountain back and keep the line of sight, the angle of sight, I should say, the same, what happens is that the line of sight or angle of sight ends up going over the top of where the top of the mountain would be. So that was my point.
Brian, if that's your point, you're going to need a better point. Let's read what you say up here at the top. If Dow Craig is close to half a mile high, then going by the diagram below, which shows the actual sizes of Dow Craig and Blackpool Tower, then between Dow Craig and Blackpool Tower, there's no more than 4 miles of distance. Brian, the entire x-axis of this sketch is compressed. Not only is the distance between Blackpool Tower and Dow Craig compressed, the distance between the observer and Blackpool Tower is also compressed. This little red line right here represents Blackpool Tower, and it's 158 meters in height. That longer red line represents the distance from the observer to Blackpool Tower. That distance is 19,300 meters. The ratio of those two numbers is 122 to 1. Obviously, the long red line is not 122 times longer than the short one. If you want to move Dow Craig to the right in this sketch, then you also have to move Blackpool Tower to the right. And you have to keep the ratio correct. What'll end up happening is you won't change the picture. You'll just spread it out. That's all. Did you not think about this, Brian?
that once that mountain moved back, right? Because obviously this is not the full distance. Like this is not like 64 kilometers between this Blackpool Tower and the mountain here. If the mountain is only just less than half a mile high, 778 meters, then how could it be this big with only this much distance between them? It couldn't be. Obviously this is an orographic view, so they're not showing the full distance between the two.
This is drawn to scale, Brian, but the scale on the x-axis is not the same as the scale on the y-axis. That's what you're missing.
So my point was, when the mountain moved back further to its full distance, then the line of sight looking over the top of the tower would end up looking over the top of the mountain. Because our opposition, the argument is that the mountain should always be intersecting the line of sight from the observer because the tower was so much lower. And I argued, obviously, that it was an optical drop and visual occultation issue. I'm not even going to show them now. I have videos out there on what they are. And I showed them with this and how it works with this and what they are. None of them wanted to hear it. They just wanted to argue against it. They didn't want to address visual occultation or optical drop.
And nobody wants to address visual occultation and optical drop because they're just red herrings in this context. That's just crap you guys have made up.
Which is not unusual. They don't want to address that and that they can't deal with. So they just wanted to ignore the whole lot. But none of them could address this. There's no way that mountain can move back, right? If it's like, there's no way that mountain, if you look at its height there's no way it can be that close to the tower. In reality, it has to be further back. So, and as it moves further back, the observer's line of sight will eventually clear the top of it. That's what happens. But they ignore that because that happened during the debate. Because we ended up having a thing during the debate. There was a problem with the way I did it on Google Earth, and this is a rectified version that I actually sent to Randy Flat Earth, someone I have no interest in talking to. This is, and when I sent this to afterwards or showed this to afterwards, they couldn't deny it or they couldn't debunk it. Randy Flat Earth during the debate, he admitted it after the break. He admitted that if you move the mountain back, then this line of sight is going to go over the top of it.
Well, that's pretty discouraging, seeing as how I just completely destroyed it in a minute, 17 seconds flat.
So, just to put all that to bed, right, because that's only a load of nonsense. Right, people can argue if they want about it, but there's no way to deny that, right? So I'm just going to put it all to bed. This is GeoGebra, right, or whatever the name of it is. Geometry software. Okay, so I have the observer here, right, at 19.3 kilometers from Blackpool Tower, which is about 12 miles. There's Blackpool Tower, right? The observer is at 6 meters here. Blackpool Tower is 158 meters high, right? That's its height. And I have Dale Craig at 778 meters and 64.38 kilometers from Blackpool Tower. So there's a 52 mile or around just over 83 kilometers distance between the observer and Dale Craig. Okay, so I'm just going to show you. I'm going to just show first. I'll just show the observer. Let's go in here.
Okay. We believe you got the right heights for Dale Craig, Blackpool Tower, and the observer. You don't have to show us that. We'll just skip this part.
778. Can you see over here? 7.78. So 778 meters, 64.38 kilometers from Blackpool Tower. Now, to the important bit, right? There is 500 meters high, right? This here. I'm just going to show here. This here. See if I have it down. Right. This is the Blackpool Tower height, 158 meters in comparison, this little purple thing here, in comparison to Dale Craig. So this purple cross here is the height of Blackpool Tower in comparison to this orange one up, this orange dot up here, which is the height of Blackpool of Dale Craig. So it's 158 meters here, 778 meters up here. I have this line here set at 500 meters. This is the angle line I brought from the observer, set it at 500 meters. Okay, so that's at 500 meters up on Dale Craig. I'm just going to show. Not that it really matters anymore, but I just want to tie up loose ends. I don't like to leave anything go. If I bring it into the tower, into Blackpool Tower, keeping it at 500 meters, as you can see, it's intersecting the tower. So if you look at the photo, the original photo, I actually should have it with me, I can't find it on my computer. The original photo, if the observer is looking about 3/4 way up the tower, they would be intersecting about 500 meters up the mountain, right?
But it isn't, is it? 3/4 of the way up that tower is where the top of Dow Crag is. Somehow or the other, Brian, 278 meters of that mountain has gone missing. The top of the mountain ought to be up here somewhere. I think you just proved Earth curvature.
So that's all fine. But my argument was, because the claim was that there's no way the observer can look over the top of the tower and not see the top of the mountain, right? That it's gone down behind Earth curve, right? Such nonsense. What other rubbish? So I'm going to go in here now, and I'm going to bring the angle line from the observer just up above, right? There's the angle line. Bring it up here. Just going to find it. Now, up there, it's at 800 meters. So the angle line is at 800 meters, right? I could even bring it down lower, if you, maybe even bring it down lower, maybe. Now 790 meters, right? So as you can see, just want to make sure, as you can see, it's over the top of Dow Craig, right? So an observer, right, with the observer, I'm just going to show, where was I going to, right? The observer's eye line is looking over the top of Dow Craig now by, I don't know, 10, 15 meters. And as you can see, they're looking over the top of Blackpool Tower. So this is only slightly over the top of Blackpool Tower, really. It's not too far above Blackpool Tower.
Well, that depends on how you define not too far, Brian. Each of those grid lines is 10 meters. Your line is about 30 meters, 100 feet above the top of Blackpool Tower. Not too far, huh?
So if they're looking up over the top of Blackpool Tower, then they will be also looking above, their angle line will be above Dow Craig. And as you can see, there is no curve to this diagram. It is horizontal, proving that when the observer looks over the top of Blackpool Tower or up at Blackpool Tower, they will not see the top of Dow Craig. Right? They will not see the top of Dow Craig. They will always be looking up in the air above the top of Dow Craig, across a horizontal plane, proving that all that Blackpool stuff, that arguments that the ballers brought, was total and utter super rubbish. They wouldn't, even though there was a black swan involved in it, it was called a Blackpool Swan for the laugh. Like, it was such pathetic rubbish. And Ranty supposedly changed sides due to that photograph. You know, it's so terrible. It's such utter rubbish. And here is the absolute proof here.
That was very deceitful, Brian. Here's my version in AutoCAD of what you just showed. This is my version of your drawing. Just like you, I've got the observer over here on the right. Blackpool Tower is right here. Dow Craig is way over here on the right, on the left-hand side. So let's zoom in just a little bit. Notice 19.3 kilometers from this 6-foot observer, or excuse me, 6-meter observer. There he is right there, the little dot. And the red line is connecting a point which is 30 meters. That's what this measurement is. 30 meters above the top of Blackpool, which is right here. And the top of Blackpool is, of course, 158 meters. So that's exactly what you showed us. Let's see what that does down here at Dow Crag. And just like you showed, that line would pass above the top of Dow Crag by 16.4 meters. 30 meters above Blackpool is a long way, Brian. What happens if we make that something a little more to my liking, like, say, 5 meters? Same thing. Now the magenta line is what we're looking at. Going from the observer at 6 meters back here. And this time it's crossing above, let me back up a second, 5 meters above the top of Blackpool. 5 meters, not 30. And now what happens? Uh-oh. Now it intersects, that's the line, now it intersects 91 meters below the top of Dow Crag. And if we drew that line from the observer right to the top of Blackpool, it's even lower on the mountain. I think something like 121 meters. But keep those numbers in mind. Again, this is 5 meters above the top of Blackpool, 19.3 kilometers from the observer to Blackpool, 64.38 kilometers from Blackpool to Dow Crag, and that's a total distance from the observer to the mountain of 83.68 kilometers. Now let me show you how easily this can be done just with some very simple math. Let's see if we can work this out in about a minute using just some simple arithmetic. We've got our observer down here 6 meters off the surface. Blackpool Tower 158 meters off the surface. And down on the other end we got Dow Crag, and it's 778 meters up. We want to make two similar triangles. So let's get rid of that 6 meters at the bottom. Just draw a line across there. We're going to ignore that rectangle for the time being. Now we got a big blue triangle and a little orange one. They're similar. The height of that little orange triangle, remember that the height of Blackpool Tower is 158 meters, but we're already 6 meters up at the observer's eye line. So we subtract 6 meters, that's 152 meters, but remember that we put our sight line 5 meters above it. So the height of that side of that triangle is 157 meters. Now let's call the height down there at the mountain x. These ratios have to hold true, so here's what we do. 157 meters divided by 19.3 kilometers has to be equal to x, the height down there at the mountain, divided by 83.68 kilometers. That's 681 meters. All we got to do is add the 6 meters back that we subtracted because the observer is 6 meters above sea level. And that tells us that anything higher than 687 meters is going to be above Blackpool Tower. Dow Crag is 778. That's 91 meters higher. And that's exactly what we found out with our drawing. You see how easy that is?
You know, that when the observer is looking over the top of Blackpool Tower, as I said, as I showed, look, right, if the mountain goes back to where it should be, then the, in comparison, if it's all scaled, right, then the eye line will go above the mountain. You know, there's no big deal about it. You know, I mean, if I move this up a bit more, I move it up to 800 meters, let's say, right? One more time we look. Now it's up even higher. So if it's already above the tower, it's going to be more even above the tower. But the point is that looking up, you won't see the looking up above the top of the tower, you won't see the top of the mountain. Whereas that's what our opposition was claiming. You have to see the top of the mountain because the mountain is 4 or 5 times higher or whatever, 4.5 times higher. And I remember trying to scale this, and I couldn't scale it simply because I just didn't have the space. I couldn't get my camera low. I had a camera that was only 9mm. And look, there you go. And I move it up to 800 meters, like the eye line, and looking over the top of Blackpool Tower, like you're seeing nothing but sky. You're not seeing Dale Craig. You're not seeing any of that. You're seeing nothing but sky. So there you go. I mean, there's absolute proof that the whole thing was a farce, and our opposition had no claims, and this absolutely proves that the Earth is flat. There's no way around that. The Earth is flat. This is exactly what I said. And there's not even and this is all autographic, there's not even optical drop or visual occultation being taken into account here. What I might do is when I get to learn how to use the 3D calculator on this a bit better, I'll try and maybe model it out in that, just to show the optical drop and visual occultation. But the point is that there you go. All their claims debunked. All their claims. So there's a 52-mile distance between these two. And this is 19.3 kilometers or 12 miles from the Blackpool Tower. And this is 64.38 kilometers from Blackpool Tower to Dale Craig. So it's debunked. There's no way around it. All our claims on that day is debunked. IONLS can copy this in this GeoGebra. So there you go. I don't know what to say. I mean, exactly what I said was true.
Here's what you can do, Brian, if you want to be honest about it. Take your drawing and move your sight line down to the top of that mountain, just like I've done. Take that back to your observer, just as you see here. There's the yellow line going right back to the observer. And this shows your picture of where that sight line crosses above Blackpool. 26.1 meters above Blackpool Tower. Clearly what we have just shown is that what you said is wrong. That mountain should definitely be higher than Blackpool Tower. You have no way to explain this photograph other than the curvature of the Earth, Brian. Now, how about being honest about it? Hey, thanks for watching. Hope you guys enjoyed it. Don't forget those little buttons down there. If you want to contribute to the channel, patreon.com/BlueMarbleScience or paypalme.me at BlueMarbleScience. I really appreciate the support, and we'll see you guys on the next one.